Hello everyone and welcome to my first video. My name is Mershad and in this video we are going to explain three fundamental concepts in Python: iterables, iterators, and generators. Let's start with iterables. Any object that can be used in a for loop is an iterable. For example, lists, strings, sets, and even range objects. Now let's define what an iterable actually is. Any iterable object must have a doneIterator method that returns an iterator object. Now it's time to define what an iterator object is. An iterator is an object that we can iterate through one by one in one direction. To do this, it must have a doneNext method. Every time we call this method, it returns the next item or raises a stop iteration exception. Every iterator is also an iterable, so it must have a doneIterator method. However, this method is usually simple and just returns itself. Here is a simple example to understand the concept better. We have a list with 3 items. This list object is an iterable, not an iterator. We can prove this. When we check whether mylist is an instance of iterable, the answer is true. But if we check if it is an iterator, the answer is false. To get an iterator, we can use the built-in iter function. It calls the doneIterator method of the object. As expected, the type of my iterator is iterator, but it's also an iterable. And remember, this is because in Python, every iterator is also an iterable. Now we can use the built-in next function to get items one by one. When there are no more items left, it raises a stop iteration exception. Why are iterables and iterators important? It's because the for loop is built entirely on these concepts. So let's see how the for loop works in Python. This for loop is equivalent to the following while loop. As you see, before the while loop starts, we get an iterator from our iterable, and in each loop, we try to get the next item from our iterator, and if it raises a stop iteration exception, we break our while loop. This entire pattern is exactly what Python's for loop does for you automatically. What is a generator? A generator function allows you to define a function that behaves like an iterator. Let's look at this example. Here we have a generator example function that returns a generator object. Notice the yield statements inside. This is what makes it a generator function, not a regular function. After creating the generator object, because it is also an iterator, we can call the built-in next function on it. First call runs the code up to the first yield and returns the value which is connected with. On the second call, the function resumes up to the next yield and returns the value Mershad. In the third call, because it hits the return statement, it raises a stop iteration exception. Let's look at another example. In this example, we have created our own custom iterable, date range. Its purpose is to allow us to iterate over a sequence of dates from a start point to an end point with a step of 1 hour. When we run this for loop, it prints these 3 lines. Because every generator is also an iterator, we can use the generator style to implement the doneIterator method. The generator starts with a start date, and in each loop, it yields the current date and then increments it by 1 hour. This process repeats until the end date is reached. If you found this video on Python's iterators helpful, please like and subscribe. We will be diving deeper into generators in a future video. All the code is linked in the description. Thanks for watching.